Today's modern world functions on electrical power, and its availability is taken for granted. Transformers are crucial assets in the electrical systems, helping to deliver electricity in a dependable and efficient manner. Electrical maintenance is a critical factor in ensuring reliable operation. In today's busy world, time to perform maintenance is reduced from days to only hours. It is important that testing conducted gives a clear indication that the transformer operates properly until next scheduled outage. The primary test performed by the Delta 4000 is AC insulation integrity, and is completed by measuring the tan delta, also known as insulation power factor. Transformers are divided into two major categories of construction and therefore into two types of testing, mechanical and insulation. Today's focus will be on transformer insulation, as we see this as the main determinant to the aging of transformers. For a typical two-winding transformer, we are interested in three key insulation measurements: high winding to low winding, high winding to ground, low winding to ground. Some newcomers to this test assume we test between phases, but it is between windings where test is conducted, as well as winding to ground. Preparations and connections. Remove all connections to the transformer bushings, including lightning arresters and bus bar. Isolate neutral winding from ground connections. We prepare the Delta 4000 by connections to transformer ground. Short all phases for each winding together, ensuring shorting leads do not droop. Connect HV and low voltage red lead to windings. Transformer is now ready for testing. We are now required to fill in nameplate information on our two-winding transformer form. This includes critical information such as oil temperature, required to evaluate test results. Next, we check off our overall test. We ensure that the proper test voltages are set for both high side and low side testing. Once properly set, we depress the test button and test sequence will begin. Once interlocks are depressed, voltage is applied to winding and tests are executed. We can now observe testing as it is automatically completed, noting any unexpected results. We review the results and determine if they are acceptable. We are now ready to test the low voltage portion of the transformer. We exchange the high voltage lead and low voltage red lead on top of the transformer. Ensuring that the proper test voltage is selected for the low side, we now depress the test button, which begins the second series of tests. Once prompted, we close interlocks at appropriate time, and test voltage is once again applied to transformer. We can observe the results as they are completed on the dialog box. Once we see the results are as expected, we can confirm good insulation condition of the main body of the transformer. For proper correction of results, we must input correct transformer oil temperature into nameplate info. Temperature can change results significantly, and so correct temperature is critical. Temperature correction graphs place all transformers and bushings into one or two categories, which is not accurate for many of our critical assets. As can be seen by this sample of actual temperature correction for various transformers, results can vary significantly. With the Mega Delta 4000 and its patented intelligent temperature correction feature, we are now confident that the results are true at any temperature we test at. With our busy lives, we seek to do more within our day, and the importance of keeping the lights on is critical. In today's world, power outages are considered significant events, which are reported and measured as a society's quality of life.